Alright, hi class. This is an experimental video that I'm recording to illustrate how to solve a problem where you choose an optimal bundle, draw some budget constraints, and stuff like that. So it might be really terrible, it might not. Let's find out. So with these kinds of questions, you're going to need some key information before you can really do much of anything. We're typically going to have a marginal utility for each good. Here I'm going to call them X and Y. On a real problem, of course, we'd give them some names. They could be apples and oranges, like on the practice test, or on the taxing labor problems, they're typically going to be labor and leisure. The marginal utility, so here I have marginal utility for X, that represents how much extra, right? Marginal means extra utility or satisfaction you get from consuming the good. Here for good Y, the marginal utility is 2. So basically, no matter how many units of Y I consume, I always get 2 units of utility. This is kind of strange because it doesn't have diminishing returns. Typically, when you consume, say, one soda, you get some satisfaction. The next soda, you get a little bit less. The third, fourth, and fifth, aren't going to provide you a whole lot of satisfaction. So the marginal utility from X here is a little bit more typical. It starts for the first good, we'd plug in X of 1, so it gives us 10 units of utility. Our second unit, it would be 10 divided by 2, so just 5 units of utility, then 3.33, and then 2.5, so it's diminishing, and that's more typical. The next set of information we'll need is the prices. If you didn't know what things cost, you just knew how much utility they give you, you really wouldn't know what to buy. You might get a lot of utility from X, so here our first unit of X gives us 10 units of utility, but if its price was $100, then it might not be worth buying. You probably don't buy a lot of pizzas that cost $100 even if they taste really good. So you have our price for X, our price for Y, and then you'll need some kind of income to tell you what your limits are. If you didn't have an income constraint, then you would just buy, say, infinite amounts of each good, most likely, right? You could get infinite amount of utility, and that would pretty much refute the basic premise of economics, which is that there's scarcity. You can't have everything, you have to make trade-offs. So the two things we can do with this information is, one, we can find the optimal bundle. So we'll start with that. Find bundle. And the way we do that is using this key condition. Sometimes it's called MRS equals price ratio, but I like to write it as what we call bang for the buck. And it basically says the value or utility, marginal utility you get from good X should divided by its price. So the marginal utility you get per dollar from good X should match the marginal utility you get from good Y per dollar. If this wasn't true, if you got more utility from good X than good Y, then you're not having an optimal bundle. You should buy more of good X. It provides a better value. If good Y provided more marginal utility per dollar, then you should buy more of good Y and less of good X. So this condition basically says the value per dollar from X matches the values per dollar from Y. If we had 3 goods, we could extend this to say the marginal utility from good 3, say Z or W or whatever, they would all match at the optimum. So now that we have this key equation, we can plug in. We get 10 divided by X divided by the price of X, so that's 2, should equal the marginal utility from Y, that's 2 divided by 1. When we rearrange this, we get 10 over X equals, 4. And rearranging that, we get X is 2.5. And now knowing that we're going to buy 2.5 units of good X, if the price is $2 each, that means we're spending $5 on good X. And if we have $10 total, we can figure out how many Ys we'll buy. That's going to be 5. So here's our optimal bundle. The first step is setting up our key equation. Marginal utility per dollar from X equals for Y, equals for, if we had Z, W, and so on, they'll all be equal. That typically gives us how much X we're going to buy. if it didn't tell us explicitly how much X we'll buy, it'll at least tell us like the ratio in which we'll purchase the two goods. And then to actually get the exact numbers for the second good, we're going to need to use the fact that we have a limited amount of income. So you'll never be able to get the exact numbers from this key equation, but it'll tell you the information you need to combine with the budget constraint, and then you'll have your actual numbers. The second thing we can do is we can draw a budget constraint and some indifference curves and think about this graphically. Personally, I'm not a huge fan of these graphs. I don't think, oh man, that's really terrible. I'm so sorry. Let me find out how to erase. Oh good, that worked. So I find these graphs sometimes are helpful, a lot of the times they're not. But when you're thinking about what you can and can't afford to buy, that's one case where they do tend to be very helpful. So typically if we're trying to divide this space up, which is a space of points like this point here represents buying a lot of X and a lot of Y, we're trying to find what's affordable and what's not. So you can probably guess if we buy a bunch of both goods, say 10 of each, that's probably not going to be affordable, right? We can already calculate that. 10 units of good Y costs $10, 10 units of good X costs $20. We only have $10, so there's no way we can afford that point out there. So let me erase that. That's totally unaffordable. So our goal is, let's find out what we can afford to buy. And the easiest way to do this is to say, well, what's the maximum amount of X I could buy? And here it would be, I have $10 divided by 2, so that gives me $5. And then what's, oh, whoops, I put that on the wrong axis. That's the maximum amount of Y I could buy. The maximum amount of X I could buy is 5. The maximum amount of Y I could buy is 10. And then I don't get any goods for free or anything. If I did get goods for free, I'd have to add those to the maximum amount I could buy. So since I have to buy everything here, it's just going to be a straight line trade-off between the two. This shape could be more complex if you got some of the goods for free, or if the price changed after you bought a certain number. For the most part, we're going to have the prices being fixed, so you're not going to worry about this budget constraint taking on any weird shapes. It'll always basically be a line segment connecting 2 points that represent what you can purchase, and then if you had any freebie goods, you might have like a vertical segment or a horizontal segment. I think you'll see some examples like that in the book. And now we could go through this thought experiment again and say, suppose I updated the income. Suppose I say, all right, you got a raise, now your income is $15. What would our new budget constraint be? Well, then we could buy 7.5 units of good X. So we'll expand this budget constraint, and we could buy 15 Ys. Obviously, this is not to scale. I have a tremor because of some of the medicine I take, so this is starting to look really terrible when I'm drawing on this iPad. I'm sorry about that. That's supposed to be a straight line. So we see when the income goes up, the whole budget constraint shifts out. If some of the prices changed, we'd only see a change on one axis or the other. So we'd have sort of like pivots and things like that. You saw some of that on the practice exam. Finally, if we wanted to, a typical problem would ask us to label the points that we pick, the optimal point that we pick. So here our original optimal point was 2.5 X's and 5 Y's. That's something like around right here. I'm going to leave it as an exercise for you to find the optimal bundle on this new budget constraint. I'll fill in roughly where it would go. It would be something like right right here. And finally, let's talk just briefly before we wrap up about about indifference curves. Indifference curves basically always look like this. They slope downward and sort of curve as you go typically, and it's basically meant to represent a point where you'd get a certain amount of utility. So at this point, maybe we have 5 units of Y, so that's 10 units of utility. Well, I have no idea how much utility this is, but let's just say it's amount U1. I could get this utility from having a whole bunch of X, like at this point, a whole bunch of Y, like at this point, or a little bit of each, like the point we picked, 2.5 X's and 5 Y's. typically the reason that we have to have a whole bunch of Y's or a whole bunch of X's, but not really that much of either if we get a mix, is that people like to consume things in, a little bit of variety. For instance, if I bought a whole bunch of pizzas and brought them home for my family, but I didn't bring any drinks home, they wouldn't be too happy. So to make them satisfied with that dinner, I'd have to bring a lot of pizza. And if I brought home a few sodas, that's not going to be as good as a little soda and a little pizza. So I'd have to bring a ton of soda to make my family happy with that. Or I could buy, like we see here, a couple sodas and a couple slices, maybe 2.5 sodas and 5 slices. And then if I had, 2 kids, they'd be pretty happy with that. And that would be a lot cheaper than this point right here, where I'd have to be buying like a whole bunch of soda or a whole bunch of pizza. Or maybe I got that back. So that's why we typically see that shape. It's always going to be tangent at this optimal point. No one really cares why that is. It involves some more higher level math, but just make sure you always show it where it touches the optimal point. It should kind of just touch it, not cut through it. So the optimal indifference curve here would look kind of like this. All right, so that's all I've got for you on the indifference curves, budget constraints, drawing these kinds of diagrams, and especially I think one of the key skills is going to be using this key equation. You've got to memorize it. It won't be given on any exams. That tells us our marginal utility per dollar, our bang for the buck for X, matches for Y, matches for Z, matches for W. Use that to solve for the optimal bundle. In general, to actually get numbers, you'll have to combine it with this information up here on what's actually affordable. For instance, once we found out that we're going to buy 2.5 goods of X, we had to use the information that, we only had $5 left, so we'll buy $5 units of good Y. If you have any questions, just email me. This video was way longer than I expected it to be, and have fun this weekend.